Hello, ladies and gentlemen, and welcome back to the finale of the 2000 Pascal paper. That's the grade 9 paper. Now, maybe you've just jumped to the last question here, which is going to be 25, in which case, welcome, welcome. And, of course, if you missed a question, you can go back and see one of the previous ones just by navigating about on my channel. But let's dive into it. It's the last question on the Pascal, and let's hope it's a good question. All right, so question 25. Triangle ABC is an isosceles triangle in which AB equals AC equals 10. And BC, the base here, is 12. The points S and R are on BC, so that BS, SR, and RC are in the ratio of 1 to 2 to 1. So if it's a base of 12, this should be 3, 6, and 3. But if we need to, we'll write that out. The midpoints of AB and AC are P and Q, respectively. Perpendiculars are drawn from P and R to SQ, meeting at M and N, respectively. The length of MN is... Okay, so this is certainly an involved question. I'm seeing some right angles. Like I said, the length SR should be 6, and we have what will amount to be a right angle triangle here. So there's certainly that information, and we have an isosceles triangle. Now, nothing immediately jumps out to me other than to write down why B, S, R, and C have the various lengths that they do. But as for the position of P and Q, that's not necessarily going to be the easiest thing. So, when I am faced with a problem like this, I like to construct the... I'm going to draw my picture, but I'm going to draw it slowly and see what I can get out of each step as I layer on more and more of the points and the lines that they ask me to construct. So, I'm just going to start off with triangle ABC. Not the best triangle, but not the worst. And so I have B, I have C, and I have A, and 10, 10, and 12. Now I know this is isosceles. Okay, AB is equal to AC, so it's an isosceles triangle, which means that A sits directly above the midpoint of B and C. Now, unfortunately, S and R are not anywhere near the midpoint. They're sort of at a quarter of the way and a quarter of the way. So S and R, when we label them, would be at the midpoints of the midpoints with A, B, and C. And we could call this guy D. For now, I don't know if I'm going to keep D in there, but we definitely label him. And D would split BC into 6 and 6. And then I have some right angle triangles. In fact, I have a very familiar right angle triangle. I have a hypotenuse of 10, and I have one of the legs is 6. So immediately I can tell that AD, the altitude of the given triangle, is 8. So before I even add in R and S and any of those guys, M and N, I think, and P and Q, already I know a little bit about the triangle just by building it up slowly. I know that it's got a height of 8. Is this going to be particularly helpful? I don't know. But it's a little bit of information, and because it's a 6, 8, 9 right angle triangle, I got to believe that that's not a coincidence. Now, for those of you who are not aware of how this works, 10 squared is equal to AD squared plus 6 squared. All right, just looking at ADC, this right angle triangle, and then this is a very common one. So 100 is AD squared plus 36. So AD squared is 100 minus 36, which is 64. And so AD is square root of 64, which is 8. However, if you do enough of these contests, there are certain Pythagorean triangles that come up a lot. The 3, 4, 5 triangle, the 6, 8, 10 triangle, the 5, 12, 13 triangle, the 12, 16, 20 triangle. These ones come up a lot, so you learn to recognize them, and when you identify them in a question, it can often tell you that you're probably on the right track. Now, I have no idea how to solve this question, so I'm not on the right track yet, but I do have a nice little altitude. And it makes me think. So if I go back here, BS, I know it's 3. I'll write it down in a little bit. And then we have a 3 here, and this is a length of 6. And P and Q are the midpoints. So we'll have a 5 here, and a 3 here, and a 4 here, and things like that. So I think I could figure out some of this triangle just by fiddling around. I know I can show that P is directly above S, most likely. But what I'm thinking is, because we have a line between S and Q, and we're talking about M and N, I'm thinking that perhaps I can figure out a little more if I put some coordinates on here. So we shift to coordinates, and if we do that, if I let, so we'll draw it a little bigger. So if I let B be at 0, 0, then A is going to be, well, he's 6 over and 8 up. So A is at 6, 8. And C is going to be 12 over from B, so he's at 12, 0. But once I have these points, I can easily figure out these midpoints that I'm told about. P is going to be at 3, 4, and Q is going to be down 4 over 3, so he's going to be at 9, 4. Okay, and I did say I would do this, so I will in a moment. S and R, we can show that they've got to be over 3, so 3, 0. And this one will be over 3 from 12, so 9, 0. So they are indeed below P and Q. Now, I've mentioned this several times, so let's actually write it out. BS to SR to RC is 1 to 2 to 1. So SR is 2BS, and RC is just 1BS. And we know that if we add them up, we get the whole side length, BC, which is equal to 12. So BS plus 2BS plus BS is equal to 12. Well, that's 4BS is equal to 12. And therefore, BS is equal to 3. 12 divided by 4. Okay? So I was correct earlier when I made the statement that this is going to be a 3 over here. So now if you were worried that, you can all stop wondering, do I have these points in the right order? Yeah, okay, I do. But now that I have all these coordinates, I can figure out, like, because I have S and Q, I can figure out, wow, that's a terrible line. I can figure out the line between S and Q. I can figure out the equation for that. And knowing what the slope of that is, and knowing that we have right angles here, seriously, what is wrong with my drawing skills today? Knowing that we have right angles here, that immediately tells me, once I know the slope for SQ, I can figure out the slope for PM and RN. I don't know what it is, but for some reason my hand just does not want to draw a perpendicular line very easily right now. Alright, so using these coordinates for S and Q, we can figure out the line SQ and figure out the slope between them. So we have to do sort of rise over run. So the y-coordinate of Q minus the y-coordinate of S. So that's something minus 0. What was it? 4 minus 0 over the x-coordinate of Q minus the x-coordinate of S. That's 4 over 6, or 2/3. So y equals 2/3 x plus b is the line. Let's sub in S being at 3, 0. So 0 is equal to 2/3 x, which is 3, plus b, which is 2 plus b. So b is equal to -2. And we could double check that. We're going to have 2/3 9 minus 2 is going to be equal to 6 minus 2, which is equal to 4. So the line from S to Q is y equals 2/3 x minus 2. Okay. So we have an equation for the line SQ. All right, that's pretty good. And we know that NR and PM are perpendicular. So PM is perpendicular to SQ, and RN is perpendicular to SQ. So their slopes, well, if we want the slope of a perpendicular line, we do the negative reciprocal. Okay, this is something that you learn when you go through lines, negative reciprocal. So we take the slope of SQ, which is 2/3, and we negative reciprocal of it. So -1 over 2 divided by 3 becomes -3/2. So we'll say A, and then Rn, we're going to give it the equation -3/2 x plus c. All right. So we have two equations, and they're just missing their x-intercepts, and they'll be the equations for PM and Rn. If only we knew a point on each of these lines. If only we had coordinates of P and R. But we do. So we can use these coordinates. We'll find A. By subbing in the coordinates of P, which are 3, 4. So the y-coordinate is 4, and we want it to be -3/2 times x plus a, so that's -9/2 plus a, so a is going to be 4 plus 9/2, which is 8/2 plus 9/2, which is 17 over 2. And we can find C in the same way. We know R is at 9, 0. So the y-coordinate is 0, but what do we think the y-coordinate should be in terms of the x-coordinate? Plus C. So -27 over 2 plus C. So C is going to be 27 over 2. Okay. Now, do these things seem unreasonable? 17 half, or half of 17 should be about 8.5. We're already at 4, so I don't think it's unreasonable to reach 18.5 by the time we get here. And this one, obviously, further out, it's not unreasonable that we would be able to reach 13.5, which is somewhere up here. we extend that line. Okay. So these are reasonable x-intercepts, and we can reasonably assume that we've done our calculations correct. So PM is y equals negative 3/2 x plus 17/2. And Rn is y equals negative 3/2 x plus 27/2. Now these are great. These are the equations of PM and Rn. But we want to find the distance between m and n. That's what the question is asking us for. Oops, I'm going to go one too far, aren't I? No, I'm good. So we're asked to find the difference between m and n. Now, if we have the coordinates for m and coordinates of n, there's a way to express the distance between them. So can we find the coordinates of m and n? Well, of course we can. We can find the coordinates of m, because m should be the intersection of the line we just found with the line SQ. And in the same way, n is the intersection of Rn and SQ. So 2/3 x minus 2 we'll start with m. Two-thirds x minus 2, and the other equation that we just figured out. Alright, so we set these two guys equal. So 2/3 x minus 2 negative 3/2 x plus 17/2. So one thing I want to do right away is I want to get rid of this 3 and this 2. So I'm going to multiply the whole thing by 6. So 4x minus 12, negative 9x plus 3 times 17 is 51. Okay. So let's bring this negative 9x over to the other side. We're going to get 13x. And then 51 plus 12, that's going to be 63. So x is 63/13. All right. And then when we substitute in for y, 2/3 63/13 minus 2. That's going to be, divide that by 3, we get 21, so 42/13 minus 26/13, and we're going to get 16/13. Okay, now let's really quickly grab our calculator and double check. Is that what would happen if we substituted in 16/13 into the other equation? Because if not, somewhere we've done our calculation error. So 63/13 times 3 divided by 2. And then we add on 17.5. And we do get 16/13. So m is at 63/13, 16/13 high. All right. So n is the intersection of SQ, which, as we just remarked, is 2/3 x minus 2. And n is also, it's the intersection of SQ and Rn, which is y equals negative 3/2 x plus 27/2. Let's just double check that's right because it was on the previous page. And we don't want to be making a mistake now by misremembering. Okay. So in the exact same way, we set them equal to one another to find the common x value. the x value that solves both equations and gives the same y value. And just like before, I want to get rid of this common denominator, so I'm just going to multiply everything by 6. We get 4x minus 12 again is negative 9x plus, and now we have to think 27 times 3. Well, 27 is 3 cubed, so adding on another 3 is 3 to the 4, which is 81. So once again, we get 13x, and then it's 81 plus 12, so that's 93. So x is 93 over 13, which is so close to dividing by 13, but still not. And then y is going to be equal to 2/3 93 over 13 minus 2, which is 31, so 62 over 13 minus 26 over 13, and we're going to get, I think, 36 over 13. 62 minus 26, yeah, 36. And we'll just double check. 93 divided by 13 multiplied by 3 halves plus 13.5 is indeed 36 over 13. So we're good to go. M was at 63, 13, 16, 13. And now we have N is at 93, 13, 36, 13. So since we have their coordinates, we can figure out the distance. We take the square root of the difference in their x coordinates squared plus the difference in their y coordinates squared. So we're going to get 30 over 13 all squared plus 20 over 13 all squared. So it's 900 over 169. You can do that with your calculator if you need to. 400 over 169. So 1300 over 169. Well, there's a 13 up here and there's a 13 down here. So we'll cancel out. We'll be left with a 1 over 13. So square root of 100 over 13, which is square root of 100 over square root of 13. But we know what the square root of 100 is. It's 10 over 13, and I think I saw this briefly in our answer key. There it is, it's B. So the distance from M to N, and we found it by coordinates, is B, 10 over square root of 13. All right. So that about wraps up the 2000 Pascal paper. Stay tuned to the channel for, I guess, the 2001 Pascal, and of course, browse around for some of the other contest videos, depending on how long the site's been up, or not the site, the channel's been up. I'm sure there are plenty of contest videos you can go and take a look at to help you practice, or just because you like watching math get done. I know it's something I enjoy, which is why I created the channel. But feel free to like or subscribe, and whatever you do, I'll see you for the next question in the next video, whenever that is. So thank you for watching, and I'll see you guys next time.